Our next speaker is Elizabeth Fisher, and she will be talking about identifying and characterizing surface absorbed water on the lunar surface.
Fabulous. So I am just going to zoom through this really quickly. This is work that I've been doing trying to answer the question of whether or not we can use lunar spectra at 3 microns to try and discriminate between surface adsorbed and internally bound water in the lunar regolith. And I think that after all the talks today, it's quite a timely subject, because to be able to answer some of these questions that we have about, what exactly is causing the diurnal variations in the hydration signature that we see, it behooves us to know as much as possible about, the form of the water that is actually causing that signature. The time scale of these variations implies that this water, it could be adsorbed, chemisorbed to grain surfaces, but it could also potentially be bound within grain interiors. So making that distinction would be fabulous. And the way that we're approaching this is we're starting by measuring lunar relevant materials in the lab. Here I have data for plagioclase and tektite. And what we're doing is we're varying the amount of surface water on our samples by creating particle size separates, which changes the surface to volume ratio. Then we can use Hapke radiative transfer modeling to account for all of the effects other than absorption, and that leaves just the absorption signature of surface adsorbed water. And here I've just got a couple of examples of data where, you can see the 3 micron features for plagioclase and glass, and you can see that the shape of this absorption is actually changing as you increase the amount of surface water. So those changes are indicating that there are, the surface and internal water have different bonding environments, and they look different in the 3 micron region. So perhaps we can detect that on the moon. And that's it. Thank you. Come to my poster.
Thank you, Elizabeth.